Hello everyone. Welcome to Controllers Tech. This video is the start of a new series, and in this series I will cover the STM32 register level programming. This is the first video, and today we will see how to set up the clock. And that's why this video is going to be very long. There are no shortcuts here. Some registers and values might be different for your controller, and that's why you need to see the entire process. I will use Kyle for these tutorials. Let's open the pack installer first. Type your MCU name, and let it refresh the database. Now you need to install the DFP pack from here. That will be all you need. Also make sure the compiler is updated. I already have them installed and updated. Go to Project, and create a new project. Give the name to this project, and click Save. Search for your device here. We only need to include the core file, and startup file from here. Here is our project. Let's add the main file to this. First of all, include the device-specific file. This file have all the registers, IRQ predefined in it. Now I am going to create a main function, and a while loop inside it. Let's create a function, where we will configure the clock. And here are the steps, that I am going to follow. First we need to enable the external crystal, and wait for it to become ready. Then enable the power, and configure the voltage regulator. Next, we need to configure the flash-related settings. Then configure the prescalers for peripheral clocks. Then configure the PLL. Then enable the PLL, and finally select the PLL as the clock source. We will cover all these steps one by one. Let's also open the CubeMX for the reference. I am selecting external crystal for the clock. I will configure for the maximum clock here, because I always prefer it, and this way I can keep the same settings for the other programs too. We will come back to this, once we start programming. Let's start with the first step. So, we need to turn the HSE on, and wait for it to become ready. This bit is in the RCC, CR register. As you can see here, the 16th bit is for HSE on, and the 17th bit is the HSE ready bit. In the RCC, CR register, set the HSE on bit. This is already defined in the header file, and it's basically writing a 1 at 16th position. Now we will wait for the HSE ready bit to set in the CR register. This will indicate that the HSE crystal is on. Let's move to the second step. Enable the power interface clock, and configure the voltage regulator. Power enable is 28th bit of the RCCA-PB1 register. We will set this bit in order to enable it. Now the setting for the voltage regulator. This bit is located in power control register, and it's the bit number 14 and 15. Just keep this to its reset value, in this case it will be 1 1. The VOS will always correspond to the reset value. Now the step 3. We need to configure the flash-related setup. To do so, we need to modify the flash access control register. Let's see the cube MX. Here we have all instruction cache, prefetch buffer, data cache, all are enabled. And the flash latency is 5 ws. All these bits are available in access control register. Let's set the flash ACR register accordingly. Now the fourth step is to configure the prescalers for the main clock, and the peripheral clocks. As you can see here, a PB1 prescaler is 4, a PB2 prescaler is 2, and a HB prescaler is 1. All these configuration bits are in our CC clock configuration register. Let's first set the AHB prescaler. AHB prescaler is 1 in our setup, so I am using division 1. Next, set the ABP1 prescaler, which have the value 4, so division 4. And at last, set the APB2 prescaler, whose value is 2, and that's why division 2. Let's move to the fifth step, and configure the PLL. We will do that by modifying the RCC PLL configuration register. Here we need to set the values of PLLM, and PLLN, P, Q, and R. You can see the values here, PLLM is 4, PLLN is 180, and PLLP is 2. Let's define these values first. In the PLLM, we can directly input the value at the bit 0. Similarly in PLLN, we can input the value at bit 6 directly. But in PLLP, we can't directly use the values, as we need to select from these available here. I have the PLLP as 2, so I need to write 0 to this 16th position. So I will simply shift this 0 to the 16th position. Let's modify the PLL configuration register now. PLLM starts at bit 0. PLLN starts at bit 6. PLLP starts at bit 16. Here we also need to select the source of PLL, which in this case is HSE oscillator, and I need to write a 1 at 22nd bit. In step 6, we need to enable the PLL. In our CC control register, bit 24 enables the PLL, and bit 25 confirms the ready status. Let's enable the PLL first, and now we will wait for the PLL to become ready. The final step is to set the clock source. This can be done in the RCC configuration register. The 0th bit is to set the clock source, and the 2nd bit is to confirm the status. Here I will use the PLLP as the clock source. Set the PLL as the clock source. And wait for the source to become ready. This completes the clock setup. Now from now onward, in most of these videos, I will use these settings as it is. So this was basically just a one-time setup. Now as we want to blink the LED, we need to configure the GPIO. Here the things are easy. Just enable the GPIO clock, set the pin as output, and configure any settings you need for the output mode. Let's start with the first one. To enable the GPIO clock, we need to look into a CC peripheral clock enable register. As you can see here, the 0th bit of this register enables the GPIO clock. By the way, I am using pin PA5 for the LED. Write a 1 to the 0th position, to enable the clock for GPIOA. In the second step, we'll set the pin as output. This can be done using GPIO mode register. Here we need to write a 0 and 1, to set the pin in as output. Every 2 bits of this register controls a single pin. For example, bits 0 and 1 controls the pin 0, bits 2 and 3 controls the pin 1, bits 4 and 5 controls the pin 2, and similarly, bits 30 and 31 controls the pin 15. As I need to set the pin 5 as the output, I need to modify bits 10 and 11, so 11th bit will be 0, and 10th bit will be 1. In the GPIOA mode register, I will write a 1 in the 10th position, and 11th position is 0 by default. Now the last step is to configure the output mode. Like what type of output we want. Default setup is for push-pull, and this is exactly what we need. Then we have the type of speed we want for the output pin. By default, it's slow speed. I am okay with it, since I am only blinking LED for now. There is pull up or pull down configuration. We will leave this to none, since we are using the pin for blinking. So all the remaining registers should be 0, even if you don't write values to them, they will be 0 by default. I will write them anyway. This finishes up the GPIO configuration. Let's write the main function now. First of all, set the system clock, and then set the GPIO. And now on the while loop, I need to toggle the pin PA5. To set or reset a pin, we need to use the GPIO bit set reset register. As you can see here, to set a pin, we need to set it in the lower half of the register. And in order to reset the pin, we need to write a 1 in the upper half. As I am setting pin PA5, I will write the 5th bit of this register to 1. Let's give some delay, which I will cover later. Now to reset the pin 5, I need to write a 1 to the upper half of this register. As you see here, the upper half starts at bit 16, so the pin 5 will be the 21st bit, and to reset it, I need to write a 1 in 21st position. Instead of doing that, I will simply write a 1 to the 5th position, and shift the entire value by 16 places. And again give the delay for toggling. Let's create that delay function. This is just some random wait time. Let's build this. We don't have any errors here. Go to Options, and update the frequency here. Mine will be running at 180 MHz. Select the ST-Link debugger. Select Connect under Reset. And reset and run. Click Download to flash the code. You can see the LED is blinking, but it's too fast to be noticed. Let's increase the delay. Now the blinking is perfect. Let's modify it one last time. And you can see now it's even more slower. So that's all for this video. I will continue this series, and we will cover all sort of peripherals here. Also a CC was just one-time setup, and next video onward, I will simply include it in the main file directly. I hope you learned something today. Things can be a bit hard in the beginning, especially if you have never worked with registers before. But you have to start somewhere. In the next video, I will cover the basic feature of the timer, and we will use it to generate the proper time delay. Goodbye till then, keep watching, and have a nice day.